Hey everybody, welcome back to another one. This time we're going to be talking about energy and industry from about 1750 to about 1850. Typically this is sort of seen as the Industrial Revolution. We'll try to get a sense of what that means, but not just looking at the change in sort of mechanical use and these sorts of things, but how that affected society, the sort of cultural changes, class changes, all kinds of new places where people were working, how they related to the job. Then in the time after this, we'll look at critiques of this whole system. So for now, I'm just going to lay out what sort of industrialization looked like, how it sort of started to make changes. Next time, we'll deal with those changes a little bit more in depth. So in about a 100-year period from 1750 to 1850, the way human beings took energy and utilized it radically changed. It causes a tremendous long-term effect, the results of which we still aren't quite sure of. We'll get back to that kind of more towards the end of the class, but really changed how people work, what sort of things they do, how they do it, and how society functions. So first we'll look at industrialization, the machines, the mechanization, the process, how that actually works. Then we'll look at the factory, the sort of location of all of these new industries, how that came together. Then we'll look at industrial capitalism, the new sort of economic and social systems that arise as a result of these changes. So when we think about industrialization, we tend to think about the 18th and 19th centuries. Human beings are going to learn to do something very strange. They're going to learn to use inanimate energy to drastically change the amount of work they can get done and the way that work then becomes part of the economy. So if you think about human beings and work, for most of human existence, we were really limited by the amount of plants or animals that we could control. All of our energy comes from one or the other, until quite recently. Human beings, this often gets described as them being children of the sun. So until the 18th century, basically however much wood grew within a year, you could harvest that much wood and you could burn it to heat your house and to cook. If you cut more than that, you would be slowly sort of depleting the forest around you. You could grow plants. The amount of plants that you could grow dictated the amount of food that you had, thus population and stuff like this. You could harness animals. Here you have a cow pulling, or you have a horse or a donkey working a gear, right? But you were basically limited by the amount of growth every year. But in the 1700s, something weird is going to happen. People are going to start to find out that there's this material in the ground, coal. This is quickly going to be followed by other fossil fuels like oil and natural gas. And these things are going to come to be used to replace the labor done by animals or replace the energy produced by food. One way to think about this, when you think about fossil fuels, right, or coal or these sorts of things, this stuff is like fossilized sunlight. At one point, the sun hit the earth, it grew these trees, those trees burned and became, fell over and became part of the ground essentially over time, or animals that were alive, shale, dinosaurs, right, you've heard that sort of thing, megaforests, megafauna, stuff in the ocean, used sunlight to grow but then eventually died, and then the carbon inside them eventually converts into these sorts of fuels over time, or the raw material for these fuels over time. So these fossil fuels are basically like little bits of sunlight that have been stored away forever. But there's a limited amount. They take a really long time to make. We're using them up pretty quickly. Again, we'll get to more of that towards the end of the course. So the first sort of fossil fuels that were in really common use was coal. There was an experimentation in China with using natural gas for various things because it does escape from the ground naturally. But the British were the first to mine coal in large quantities, and there's a particular reason for this. During the 1700s, wood was simply becoming more and more scarce in Britain. It's an island, it's not tremendously big, it had a relatively big population. Wood was in heavy use for ships, homes, heating, cooking, and the forests around Britain had been pretty well depleted. So people were looking for some kind of alternative source of energy. It so happens there's a lot of coal in Britain. It's just an accident of nature. And it was relatively close to the surface compared to other fossil fuels. So when these large deposits of coal were found, and it was found that you could burn coal and produce heat and produce energy, there's really quickly this movement to try and get this stuff up out of the ground and see what could be done with it, how it could be used instead of wood, particularly for heating and cooking. But this was an incredible, horrible process. Working in the mines was really difficult. There was no modern technology, so these mines were dirty, they were dark, they were really hot. Here's some newspaper drawings of these mines, these sorts of figures here showing what it was like. You can see these people are wearing very little clothes because it's really hot. They're very hunched over in these passageways because there's not any steel or anything like that really to be wasted to buttress these things, so these things collapse, so you can't make them very big. Lots of women and children were used in these mines because they're smaller. It's horrible conditions, a really high mortality rate, absolutely awful. But the coal that they were able to produce radically changed Britain. It made them capable of generating more energy than was produced per year. So there was sort of this excess supply of energy trapped away in the ground, and in this moment, the British were able to take that and use it. In particular, this leads them towards some technological changes that are going to have huge impact for the world. The first sort of steam-powered engines were used in these mining operations. So where they were mining coal, often these mines would fill up with water, and you would have to get the water out of the mine if you wanted to keep digging. So some of the earliest mechanical devices burned coal because there was a lot of coal right there. They were at the mine. So they would burn a portion of it so they could produce force to draw water out of the mine so they could keep mining them. Very simple designs on these engines, very inefficient. By the mid-1700s, James Watt had developed the first steam engine that would be much more useful for transportation and locomotion. I'll show you that in just a second. And these things often get measured in horsepower. Literally, it was the equivalent of what a horse could pull, right? You've seen these sorts of things. So how does it work? Really, basically, you take coal and you burn it. This produces heat. That heat is used to turn water into steam. When you turn water into steam, it changes the pressure, right? Because as water gets converted into steam, there's more space, so that increases the pressure. That pressure can be used to move something, right? It can create mechanical energy. That mechanical energy can be used to do work. I'll show you a little video of how this works. It's pretty interesting, some of these early machines. If you're hip to engineering and all that sort of stuff, this can be really cool. Check out how he's laying out not only how these machines were made, but sort of how it was that they started to make them more and more efficient.
Over the course of human existence, the most significant catalyst for growth has been our ability to draw energy from our world. Taming fire gave birth to the modern human, and drawing power from the wind allowed early explorers to travel the world. But today, we're going to explore the history and science behind one of humanity's greatest inventions, the steam engine. The evolution of the steam engine completely revolutionized our society. It opened new avenues for trade and caused mass migrations of rural populations into the newly industrialized cities. What I found most fascinating was the lessons its evolution taught us about science and engineering. This is one of the first practical steam engines, and it was used to pump water. The engine was incredibly inefficient. This machine was not going to start any industrial revolution, but it found a niche in coal mining, where its fuel was cheap and readily available. To investigate why this engine was so inefficient, let's first talk about how it works. The engine takes energy stored in coal and converts it to heat. That heat is used to form steam, which expands into a piston cylinder, causing the pressure to increase and forcing the piston to rise against atmospheric pressure. No mechanical work occurs on the stroke because this chain can only transmit force in tension. The power stroke occurs when cold water is sprayed into the cylinder. This lowers the temperature, causing the pressure to drop. Atmospheric pressure now pushes the piston back down. We want to be able to quantify how much work is being done per cycle of this engine. To do that, we plot the pressure and volume inside the piston cylinder for one cycle, like this. The area inside is the work done, but this is the idealized PV diagram. In practice, there is a lot more energy being wasted. We lose a big chunk here because the steam is prevented from expanding to its full volume. A lot of energy is lost to the environment too. This is clearly visible with thermal imaging. The effect is made worse by cooling the entire cylinder with cold water. So an immediate improvement is to make a separate condenser. Here the steam can be cooled without cooling the entire cylinder. There are a lot more inefficiencies involved that reduce the total work done. Many of them are unavoidable, but we can improve the situation by upgrading the piston cylinder. The manufacturing techniques needed to bore accurate and strong piston cylinders were not available in the early days of the steam engine. That changed when John Wilkinson invented this machine. This boring machine allowed for precise machining of solid iron cylinders, which reduced steam leakage and made the piston cylinder stronger, thus allowing the max pressure to rise. We are starting to see a steam engine capable of sparking an industrial revolution. But this reciprocating motion isn't much use for most applications, especially with this flexible chain connecting them. What we need is rotational motion, which requires a different setup. To convert this linear motion to rotational motion, we need a crankshaft and connecting rod. We have turned this piston cylinder on its side, so atmospheric pressure can no longer force the piston back down, so we need to use steam on the return stroke. This requires a control valve to control when the steam enters and leaves each side of the cylinder. The valve is controlled by a cam. The steam engine is now working on both strokes of the engine, improving its efficiency and power. But piston engines like this do not produce constant torque. They'll pulsate in speed and torque during a single cycle, like this. This can cause vibrations and jerky movement. We can reduce this with the use of a flywheel, which stores rotational energy with inertia and evens the torque out. It's essentially a mechanical battery. David Robert demonstrates this beautifully with the V8 solenoid engine of his own creation. Here you can see the engine will continue to rotate without additional power, but the engine comes to a dead stop without a flywheel attached. The development of steam engines taught us a lot about thermal and mechanical efficiencies, and you may think that steam engines have become obsolete, but nearly all of our large power stations still use steam technology to convert heat energy, whether that be from coal, nuclear or solar, to mechanical energy. The technology has simply evolved into an even more efficient form, with steam turbines. Thanks for watching. I have one last device I want to include in the development of steam engines, which is one of the most iconic inventions of the Industrial Revolution, the centrifugal governor. I'm already hearing the angry screams in the comment section about me using the word centrifugal, so I'm going to talk about this device in a completely separate video to discuss the differences between centripetal and centrifugal force. If you'd like to see that, don't forget to subscribe. If you'd like to see more content or support Real Engineering, the links for my Patreon, Instagram, Facebook and Twitter accounts are below.
Okay, so that was pretty cool. Yeah, that guy really shows some of those early techniques, how the engines actually work. A lot of time that gets skipped over. I mean, now people don't know how anything works, right? We all have cell phones, TVs, heating, cooling in our house and stuff. Nobody really knows how it works, which is kind of weird. So it's interesting to see these sorts of early machines where you can just see physically how they're working and what people were doing. That's a great kind of first step. So this map here is sort of showing where these early coal deposits were around Britain. You might not be able to see it super well, but all those little red dots, that's where industrialization was emerging. Then if you look a little bit closer, there's these sorts of purple areas right here, these places. That's where there was a lot of coal sort of naturally in the ground. So you can see that these are connected, right? Where there's coal, that's where sort of industrialization is happening. If you're too far away from the source for these materials, you're not going to be able to make that transition to using those materials to sort of fire up your revolution and get things moving. They're kind of going hand in hand. Using this new fuel demands new technology. The new technology helps you get more fuel, right? It's kind of back and forth. This leads to machines. This sounds really intuitive, but we don't actually talk about this stuff too much unless you had to take like a shop class in high school or something like that. A lot of things that are mechanized we don't really think about too much, but it's a little bit interesting. Machines basically use mechanical energy, right? There's some sort of force involved. It's not electronics, it's not biological, but it is made to imitate human actions. Or animal actions. So a car basically imitates my ability to ride a horse, right? You can ride a horse, but that's not going to get you anywhere nearly as fast as a car. I could sew something by hand if I learned how to sew, or a machine can sew it for me really, really quickly. I can take a sledgehammer and I can try and break up some concrete that'll take me forever. If I have a jackhammer, right, it won't take me very long at all. So machines imitate human action or animal action, but they're powered by this other sort of mechanical energy, right? They're powered by either fossil fuels or sometimes by burning wood, stuff like that, sometimes rotational energy, stuff like this. And they can be hundreds of times more productive than human labor. So in this picture, right, you have a kid, we'll talk about child labor and all that sort of stuff next time, but you have a kid that's working in a thread mill, right? So here they are making spools of thread. So you have this one kid going up and down the line, basically just making sure that everything is working okay. Meanwhile, hundreds of spools of thread are getting made. If he had to make those himself, it would take forever, right? But if you just have him monitoring the machines can do it much, much more rapidly. In particular, this is not just an accident, I'm showing thread. The sort of earliest transition from these engines from helping with mining to actually serving in other types of industrial use was in Britain in their textile mills, making cotton, wools, thread, stuff like this. Then, pretty quickly, people see that these machines are great at producing mechanical energy and at doing work. Well, what sort of things are really laborious? Getting around is pretty difficult, particularly if you have a lot of stuff to move. I might be able to move 100 pounds, a certain distance, but I'm going to get tired pretty darn quickly. But if you put 100 pounds in a car and drive around, it doesn't really change the fuel efficiency all that much. So these machines were starting to be made that could transport things, that could move lots heavier loads, and some of them are a little bit unexpected, or you might just not think of them first off. But in 1807, you get the first commercial paddle steamer. You guys might know what these are. These are boats that have like the big wheel in the back, right? If you've seen like old cowboy movies or movies about like Mississippi or something, right? They often have these. There's one in Ozark or something, right? They have them. So these are just like big boats that have the big wheel in the back that spins, and then they have steam coming out the top of them. But they're great for moving things up and down a river because you don't need wind. You can go right up the river. Previously, this was really difficult, right? If you're trying to go upstream in a boat, you might be able to do it with wind, but not very well. With steam power, though, you can just motor right up a river. Then this is followed quickly by this first steam locomotive. By 1837, you get the North Star steam locomotives. That's what's drawn here. These are commercially available. They're widespread. They're sort of standardized gauged. This is when you start to get a real revolution in transportation. You can have a train, a steam engine, pull thousands of pounds, and as long as you have the track, you can take it anywhere you want to go. These sorts of commercialized products really change the economy. Previously, moving big, heavy things that weren't very expensive wasn't done as much. However, now that you can move giant amounts of stuff that's really heavy, you can still make a pretty big profit off of moving things that aren't that expensive, like salt or wheat, even things like water, right? And so things that are really heavy, hard to move, but not really high price, become much cheaper, much more part of the sort of global economy and wide-moving economy. And there's all kinds of new transportation possibilities. Once you have a railroad, you can go across the United States, say, in just a few days, right, instead of a few weeks. So it really changes how goods and people can move back and forth. Of course, that's going to have a huge effect on economies. So what do you do with all these big machines? You can move things, you can make things, but there's a new sort of infrastructure that's required. Machines are really big, they're really heavy, they're technical, they need lots of fuel. So you can't just have these things out in the middle of nowhere. You need some place where you can bring all this stuff together. New centers where there's going to be a lot of labor, there's going to be manufacturing, there's going to be production, there's going to be resources, the factory, right? So previous economic systems didn't have something like a factory, not in the same sense. A lot of economies around the world were agrarian. These are village-based farming communities. Of course, you had cottage industries. You know, every village needs someone to make the shoes, or someone who makes the beer, or someone who specializes in certain tools. So you had local people that would specialize in a certain product that they could make really well or that they could sell. You had rudimentary banking and other things like this. In cities, you would have trade guilds. So you would have like the locksmiths, for example, who would train young people to make locks, and then those people would become part of the guild, and then the guild was sort of like a union where all the locks would have been made, you know, in these sorts of houses, and then distributed or sold out in the community. But by the late 1600s, with the rise of sort of Spanish and British colonialism, something new was happening. It's called the putting out system. Not nearly as exciting as it sounds in that sense, but basically what people tried to do was they tried to get around the guilds, they tried to get around the city. Big investors would have whole ships full of cotton, say, brought from India back to Britain. If they went through the city guilds, they'd have to pay taxes, they'd have to, you know, deal with all these people. Instead, what they did was they would go out to the countrysides. They would put the cotton out in the countrysides. And they would say, okay, why don't you spin this cotton into thread for us? We'll be back in a couple months. We'll pick up all this stuff, and then we'll pay you for that. Primarily, this was women in these industries. They were the ones seen as having free time, despite being required to work on the farm and work in the house anyway. But these were sort of proto-industrial tasks that could be done in the home. And this used to be, even until the 1980s or 90s, sort of a big part of the economy in informal ways. Like my mom, for example, sewed baby bumpers at night. And she would get like these patterns from someone. She would, every night, maybe from about like 8 o'clock to 9 o'clock, she would like sew these things she had on the machine. And then someone would come around once a month and like pick them up. So these things used to be a lot more sort of part of the economy in one way or another. Proto-industrial tasks, other ones that are sort of familiar might be mining or plantation slavery or large-scale sort of agricultural endeavors. These consist of very large pools of unskilled labor, and by unskilled I don't mean no talent or something. I just mean not any particular one thing you had to know or be trained on. For mining, right, it's still very rudimentary. For plantation slavery, of course, people were forced to do whatever sort of work was required of them. So this isn't quite industrialization. It's not job specialization in that way, but it's going to enable a lot of industrialization. So when we think about the factory, this is kind of tricky because now it's sort of so commonplace that actually it's gone away and we don't even think about it anymore. But by the late 1700s, there were a lot of machines starting to be developed that could do commercial work, that could make products. But they're really big, they're really expensive. You couldn't just have one in your house. They couldn't be in a rural area completely because how would you get the coal there? How would you ship things out and stuff like this? So there was a demand for some sort of new centralized location where the processes of industrialization could happen. This comes to be the factory, and it's like everything that's pulled in together to make something, and then the product goes out from there. So you bring in the labor, right? The people who are going to run the factory. You bring in all the raw materials, sometimes from the countryside, sometimes from colonies. You bring in all the fuel from the mines. You bring in all the machines from other factories. And then you need transportation nodes. If you look at this image, here you have a factory, but you also have the railway line. It's built on a river, right? This is to allow For transportation, obviously with factories, you need a lot of water for cleaning or industrial process. So you want all this stuff sort of together, but you also need unexpected things like housing, commercial stores. So here you have a factory, and then right outside you see these little houses. These houses are where your workers live, because you don't want your workers to live really far away. When the factory's open, you got to have them kind of close by and working, right? So you're seeing a new sort of setup for where people are living is kind of close to where they're working. People would have been used to this, right? If you work on a farm, obviously you live on the farm or nearby. But this is a little bit different. You're in a sort of different type of housing. This is sort of apartment housing, right? These are apart from each other, but not very much, right? These rooms kind of right on top of each other. So lots of new stuff combined here into the factory. So, but what does it actually look like inside the factory? What are people doing? So remember, the idea is you have machines that are going to do most of the work, but then you have people that are making sure the machines work, people that are moving the product, people who are working on one particular task. So unlike previous jobs or farm-based living, in factories, you don't make something. As an individual worker, you do a particular task. This is often talked about like as a pin factory, right? Adam Smith wrote about these things. The idea is, say you're in a pin factory. Well, you'd have, one person who's responsible for making sure the steel all gets processed into the factory. You have another person who's responsible for putting big spools of wire up onto the rack. You have another person who pulls the wire down the rack. You have another person who cuts the wire at various parts. You have another person who straightens the wire. You have another person who sharpens the end. You have another person who puts the pins in the box. You have another person who puts those boxes in bigger boxes. You have another person who puts those onto the, the boat. So you have all of these other jobs, but nobody actually makes a pin. People just make little parts of it, right? So this is really different from the human experience before. If you were a shoemaker, you may have tanned your own leather or you may have bought it, but you bought the raw materials, you had an idea for what you wanted to make, you made it, then you sold it. When you work in a factory, that's not how it works at all. You only do one little piece of the whole job. And you might not even do that. You might just check up on the machines that are doing one piece of the whole job. So factory work is really different in terms of individual responsibility and your connection to the thing you're making. Factory work also comes with lots of interchangeable parts. For example, you might know Eli Whitney, right? It's a big sort of name in the South, obviously. 1793, he creates the cotton gin. This is like one of the worst sort of historical accidents in a sense. He thinks that this is going to be great because it's going to make cotton more lucrative. It'll sort of increase productivity in the South. But what it actually did was make slavery way more lucrative in the South, and actually encouraged Americans to engage even more in slavery because cotton wasn't a very good plantation crop before the cotton gin. It's got all these little seeds in it that you have to pick out by hand. It's a pain. But after the cotton gin, it really becomes economical to grow cotton in the South, which becomes more invested in the slave system. As that was happening, Whitney got discouraged by what he was seeing and went into another career field, muskets. So he started to manufacture guns. Many of these were used in early American wars and the Civil War, stuff like that. But one thing that he did that was really unique and really interesting was, instead of making one finished product, you have a musket and you just use it until it breaks down. He had not only made the muskets, but made the individual parts for it. So if a part of your musket broke down, you could take that part out, throw it away, buy a new part, put it in. By the 1800s, this was a really common technique around the world, this idea of interchangeable parts. This is really funky because this also describes working in a factory. I might be in the pin factory the guy who pulls the wire, or I might be the person who sharpens the individual pins. And if needed, I can switch positions, right? I'm, in a sense, an interchangeable part in the broader factory. The machines themselves come to have the same thing. We make things that can be adjusted. If you buy a gun today and there's something wrong with the trigger mechanism, you don't have to throw the whole thing away. You can take it in and get it repaired, right? They'll put a new mechanism in. I mean, who knows how expensive that might be, but you could do it. And so this idea of interchangeable parts, though, really revolutionizes commercial products. Previously, you might have something that's made for your use, but when it's broken, it's kind of gone. Once you manufacture on a massive scale replacement parts, things are a lot more disposable in a sense, the individual parts, but the whole thing might last longer because you can replace broken bits. Also, with factory living, very quickly there becomes a split between the types of people at the factory and the sorts of outcomes for individuals. You basically get two different groups. You get the people who own the factory and the people who work at the factory. And their only real connection is that they're, centered around the factory, but the class distinctions become really big. You get a wage class. Here you have on the left these sort of working folks. Then you get the owning class. The working class is not paid for what they produce, right? They're going to be paid for their time. So they're wage laborers. You go into the factory, you have a 12-hour shift, you get paid so much an hour, and you go home. The owning class doesn't necessarily make money like that. They make money because they have stuff already. They own the factory. The factory produces wealth for them, but it has nothing to do with time scales or anything like that. So we'll see more and more of this sort of division and what becomes of that in the next lecture. But one thing that's really unique about the factories that's so different, again, from previous forms of economic activity, is this idea of standardization and mass production. So the whole idea behind the factory is to be able to produce more stuff more quickly and to have a really uniform product. My guess is if you've been to Chick-fil-A recently or McDonald's or Burger King or whatever, and you have a thing that you like and you order it, it's basically the exact same every time, right? That's that standardization. So if you're making blankets in a factory, the blanket has to be exactly the same shape and size every time, right? That's the whole point of the factory. The quality, the quantity is really standardized, but you just make a lot of it. So you have to have new sort of ideas to make this work. Things like quality control, spot checks. Here you have women sewing, and you have managers or people on the floor making sure that what they're doing matches the standards they're supposed to be. If you've ever worked a job, you're probably familiar with this. There's people watching to sort of make sure that the standard is where it's supposed to be, that you're producing quickly enough. And the idea is, particularly in a factory, it's all about speed and volume. If you can make more product more quickly, you're making more money, right? Because you've already bought all the machines, you already have all the labor. So then what's going to be the thing that increases or decreases your profit is going to be how quickly you can turn all of that labor and materials into material and how much material you can get out the door. So industrial capitalism is an economic term that describes an economy, and it's going to develop as nation states begin to transition from being farming economies, agrarian economies, into industrial societies. It's not uniform, it's not overnight, it's different everywhere you look, but it's slowly the sort of way societies are going to be curving over the next 100 or so years once this process starts. So industrial capitalism, we might define it as a sort of economic model based on industrial production, wage labor, mass production of goods for an increasingly globalized market. There you have it. It's a sort of basic way to say what it is, but we'll get into what all this means. Basically, when you start to have industrial societies and factories, you make a new relationship between production and consumption. So Adam Smith actually wrote a lot about this, right, in his book Wealth of Nations. Again, he was writing about mercantilism as opposed to capitalism sometimes. He wrote extensively about that sort of pin factory analogy, but he also wrote about things like supply and demand and the invisible hand. We talked about this a little bit before as these sort of Enlightenment ideas. Supply and demand being, if you have a lot of product but not much demand for it, the price will be low. If you have not very much product but a ton of demand for it, the price will be high. These sorts of things. It's not clear that that's true, and there's lots of problematic reasons for it, but that's a really basic understanding of how some economies work. The invisible hand referred to here is the idea about setting prices. If you make a product and you set a price and people will pay that price without even blinking, maybe you set your price too low, right? So there's like a natural thing that might raise that price, because if that price raises and people will still pay for it, things are going well. If you set your price up here and you're not selling, someone else might come in and make that same product and sell it down here, and all of a sudden it sells really well. The market is acting, right? The people, the consumers, the product are all speaking to each other, and they're finding a balance of what things should cost. He's also talking about how government shouldn't be involved in regulating these prices, right? Because the market will do it itself. If something's too expensive, people won't buy it. If things are nice and cheap, people will buy it until there's no more of it, all that sort of thing. But this really begins to change more and more as the merchant class goes away. So by the early 1800s, merchants who had been the sort of economic engine and sort of main earners during sort of mercantilism and sort of oceanic capitalism and early colonization, they're going to sort of lose their role at the top rung. And the people who are going to be at the top of the economic world are the people who own factories. The power they can bring to bear via machines is simply way more than anything else that's available. So if you own a factory, if you own the machines, you can bring in lots and lots of labor, you can bring in lots of people, you can bring in lots of materials, and you can make so much product, you can just sort of overwhelm markets. The idea being there's no limit to productions. If you can have more machines, bigger machines, faster machines, you can produce an infinite amount almost. But you have to be able to create demand. And this is where it gets tricky, because according to the idea of supply and demand, there just is a sort of demand. But what people find out really quickly is they can make more blankets than they can sell, right? Once you have one really nice blanket, maybe a second one is cool, maybe a third one even. But after that, you just don't need any more. So you have to open new markets. You have to convince people they need more. You can do this by putting out a new model, right? Yeah, you all have gray blankets, but what about a blue blanket, right? Or whatever. So you have to sort of find ways to increase consumption. Along with this, you start to see things like copyright law and this idea of intellectual property. So there was some sort of antecedents to this, right? Like authors for books would be noted and people would know it was theirs and stuff like that. But when it came to technology or products, there wasn't really a copyright. There were famous artisans who made things, but the idea that someone could make something and it was like their intellectual property, or they had created it and thus they were the only ones able to sell it, nobody had thought that way. Once factories become more and more common and machines become more common, people are coming up constantly with new ways to make things, new machines, and they start to guard this information. Because if you have the machine, or if you know how the machine works, you could do the same thing. So there becomes this idea that governments should protect people from infringement, protect people from being copied, right? That someone makes an engine, a new sort of mechanical engine, that it's their intellectual property and they should be the only ones allowed to sell it, or they should be able to sell the rights to it to a company to be able to sell. So we start to see like the Statute of Anne in Britain or the Copyright Acts in the US that are designed to preserve people's intellectual property and rights to produce a product. This is what built the Industrial Revolution in some ways, because there's all this sort of competition to make new copyrights, new machines, to sort of hop over each other in terms of who was able to produce the most, the quickest. And it becomes a sort of national issue. For example, in Britain, they attempted to keep secret all of their sort of industrial technology, but this leads to things like piracy, cooperation, espionage, right? All of these sorts of things come out of the woodwork in a way that they didn't really before. Your village shoemaker would have learned to make shoes from whoever was doing it before, or maybe his or her parents. But in the sort of industrial world, that's not how it works, right? Another part of industrial capitalism that's absolutely required for it to work is the development of big business and financial institutions. So in the 1850s, for example, you're just starting to see the development of corporations, trusts, cartels, things that you really don't need when business is at a smaller scale. We already saw the early development of stock markets in Europe, but with the Industrial Revolution and with the sort of need to control and regulate capital, you see way more financial institutions and instruments develop during the late 1700s and early 1800s. There's an explosion in banks, brokerage houses, stock markets, all kinds of different financial contracts, ways of buying into companies, ways of investing, ways of utilizing capital essentially to make money rather than time or effort or product sold. And you start to see things, the very, very early level here, sort of like horizontal and vertical integration. So many of you have probably heard about these things before. It's taught in economics classes, it's taught in history classes. But horizontal integration means a company kind of owns all of one type of thing. So if my company owns all the gas stations in Georgia, for example, every time you go get gas, you're giving me money, right? So I kind of own things across the board in one category. Vertical integration is kind of different. It means I own every step along the way in making and selling a product. So I own the oil wells, I own a factory that makes the machinery that pumps the oil, I own the trucks that carry the oil to the refinery, I own the refinery, I own the trucks that send that gas to gas stations, and then I own a gas station where I actually sell the gasoline. So like every step down in the ladder, from raw material to finished product or even post-finished product, I own. So these different types of integration start to appear where you get big businesses that are either sort of controlling all of the different options for buying and selling the product, or all the sort of ways the product is made and sold. And this is going to continue to grow, particularly in the United States and Europe and places like Japan. And it really does have that sort of global implications. It's not just in Europe. You start to see not only every place around the world impacted by this sort of transition, you see a sort of international division of labor. So places like the American South grow tons and tons of cotton. But that cotton's not really used there. That cotton is sent to Britain, or it's sent to the northern half of the United States to be made into a finished product via factories. Or you see lots and lots of food produced in Brazil, and then that food is sent to Europe that feeds workers that then produce these finished products. So different nation states, different areas do different aspects of the labor almost in a similar way to the in which factory work is sort of divided into pieces. You also see bigger and bigger gaps between raw materials and finished products. And the countries that tend to produce more raw materials tend to be seen as less productive than the ones that produced finished products, because the idea is there's a sort of added value with the finished product. Yeah, having a bunch of rice is good, but if it's totally unfinished, if it's just picked, maybe I don't like it that much. But if it's whole and cleaned and made into rice noodles, well, that's kind of cool because I can make a stir fry with those or something, right? So rice noodles are more expensive than just plain rice. So there's sort of a value added in the production process. Also, you start to see commodity chains that stretch around the world. And we saw some of this earlier on with the Spanish, say, going to the Americas, getting silver, that silver going to the Philippines, going from the Philippines into China, and then being used to buy Chinese products that were then sent back to Europe. But with industrialization, you might have, if you're wearing some shoes, check out where they're made, right? They're probably made in Vietnam or China, Indonesia, but the materials are not from there. The materials are from all over the world. The designs were made in New York. Nike's headquartered in Oregon. You might have laborers from Vietnam working in a factory in Indonesia. It's crazy. There's all these sorts of different routes that things have to come together to produce commodities and to produce products in these sort of global networks. And there is a level of resistance to it that we're going to see developing. Some places don't want to be caught up in these sorts of networks. But here you have a Japanese factory, right? So these are silk production in Japan. So these ideas travel around the world really quickly. And sometimes they're incorporated, sometimes they're resisted. We're going to see a lot more of that coming up. So between 1750 and 1850, the way human beings harnessed and utilized energy really changed, and we started to see some of those long-term effects. Next time, we're going to look at critiques of this system and try to understand what it did to society and how some people pretty quickly came to view industrial capitalism as not a great system and as creating lots and lots of problems. It had a tremendous amount of benefit in some sense. In other ways, it's a pretty horrible system. We'll kind of try to weigh those out and see what's happening. As always, let me know if you have any questions. See you next time.